So if we could get our 5 science panel members to come up, and for Louise and Craig to come up. And Philip and Kirk are going to continue to kind of moderate the discussion around this topic. And so the idea again here is to really engage, to get the science panel members to really engage with the consultants, and ideally they would be facing each other so we can have that conversation. But we're sort of limited on space and the ability to do that in a filmed environment. So I'll go ahead and turn it over to Kirk and Philip, and we'll get started. Thanks.
Looks like most everyone's back, so we'll get started. And I guess one thing we should state is that Kirk and I decided to start with geology, physiography, and soils because it's really the framework for what a lot of the other studies need to know for working on their aspects. And it's not necessarily what the most controversial piece of this baseline report is, but without understanding the physiography or the soils, you wouldn't necessarily know with precipitation how it's going to move into groundwater and how surface and groundwater interactions occur, or understanding mine site geology is critical to understanding, what minerals are there for water-rock interaction. So we realized that there's probably more controversial ends of the report, but we felt it was really important to start with the framework of what the geology, what the soils are, what the terrain looks like.
Yes, as Philip said, geology is the solid framework, and that's the first day and a half of these sessions, and that follows with the fluid framework, that is the water and the water quality. Now, we're going to start with the panelists that we have up front here, who've been introduced already, and we're allowing them some time to ask questions of the presenters and also to provide further comments and criticisms. And
should we start with Jeremy?
Yeah, I guess we'll start at the end with Jeremy Richards.
Okay, thanks very much. I think, as you mentioned, the geology is probably the least controversial bit of the EBD. It's probably also the best studied section because they've been looking at this for years due to exploration. So the deposit itself is very well characterized. To the point that they've been able to make an economic evaluation. So it's obviously in industry's interest to characterize the deposit extremely well geologically. So for those of you who are not familiar with what this type of deposit is, it's basically a deposit in which you have scattered grains of economic minerals, and in this deposit those minerals are mostly chalcopyrite, which is a copper iron sulfide, a little bit of molybdenite, which is a molybdenum bearing sulfide, and that's about it. There's a little bit of bornite, which is another copper iron sulfide, and there's also gold, which mainly is associated with those sulfides. Most of the gold is not present as free gold. So when you process these deposit types, you're extracting, in general, you're extracting those sulfides to get at the metal components. And the deposit type itself is geochemically fairly clean in terms of contaminant metals. There's many other deposit types that have a lot of things like arsenic and mercury, which are major concerns from an environmental point of view. This deposit type typically doesn't have high levels of those elements. But what it does have, and probably what's the greatest environmental risk from these deposit types, is it has a lot of pyrite. And again, for those of you who don't know what pyrite is, it's one of the simplest sulfides. It's just a simple iron sulfide. In general, it's not of economic interest, so the pyrite is usually considered to be a waste material. And the problem with pyrite is that it oxidizes very quickly in the surface environment and it makes acid. And as many of you know who follow the mining industry, one of the biggest problems with mining is the generation of what we call acid mine drainage, which arises primarily from oxidation of pyrite in the surface environment. So I guess one of the questions I would like to ask the consultants is about the distribution of pyrite in the deposit, in the known rocks in the mineralized system, and how much of that pyrite is considered waste, and how much of that pyrite would actually be processed to extract gold, which would essentially remove it from the waste stream, and so it would be treated. That aspect of it, I didn't really get a very clear understanding from the baseline study. Now, understanding that there's no mine plan in there, but also we're saying that we're viewing this from the point of view of ultimately building a mine. So ultimately, you're going to dig that stuff up, and it's going to contain pyrite. So could you tell us perhaps a little bit more about the distribution of pyrite? How much of that is going to get into the waste stream? How much of it will be processed and shipped out in concentrates and so forth?
Because there's no mine plan yet, I don't really know if I can answer that question until they actually know how much rock will be removed and where they're going to put it, and
Right, but presumably they have a fairly detailed three-dimensional model of the ore deposit, so they must know volumetrically how much pyrite there is here and there, what proportion of that is considered waste, is out in the quartz-sericite pyrite zone, which would presumably go into the waste stream, and how much of that is considered ore and will go into the processing stream. Is that not a reasonable thing to ask at the baseline level about knowledge of the geology of the deposit?
I don't actually have that knowledge myself, but Paul Jensen is here from PLP. Maybe he would be able to answer that.
Would you like that? Can you just introduce yourself briefly? Thanks.
Yeah, my name is Paul Jensen. I'm the chief geologist out at the Pebble project. I've also worked up at the Pogo mine as chief geologist and over at Fort Knox in the True North mines. They're up by Fairbanks. In response to that question, the treatment of the pyrite it's a complicated issue right now that the metallurgists are going into. They have to look at the value of removing all of the pyrite from the stream to go ahead and treat that for gold. What is the economics of that versus putting it back into a tailings facility, maybe a submerged facility to try to keep it from oxidizing. That is all being still worked out. So we don't have an answer to how much pyrite would be left as far as the process stream. As far as the waste rock, the rock that clearly doesn't have enough copper or gold or both together and moly to warrant putting through the mill, that material, we know that is potentially acid generating, and that will be on waste rock piles. So a different thing. So I'm afraid, yes, we know that there's a lot of pyrite. The gold is outside of the copper centralized portion of the deposit, and it is with that pyrite. The gold is also with the chalcopyrite in the central part of the deposit. So, though we've had some time to evaluate this, the metallurgists are still running samples just to determine that, but also the economic benefits of how do you do that if you don't go ahead and recover the gold from that pyrite? What do you do with it? What are the costs of that? That's all still being determined right now.
Okay. Thanks.
Thanks, Paul. Thank you. Any other questions, comments, or should we move on? Or?
I'll hold for now and let other people have a go.
And Larry, would you like to bring something up?
Yes, this is in reference to the soils work. It's my understanding from NRCS office in Palmer that there are no PDON reference soils in the Lime Hills area where the deposit is located. And because of that, you don't have any way of really having some sort of a reference to go to compare. But what I'm interested in is this was mainly a desktop study. Is that correct for the soils? Was there very much on the ground truthing of the soils work, or was it basically literature review?
Yeah, really just some of the soil thicknesses in the mine study area is really the only kind of ground truthing that we have. Yeah, we showed maps of quite a broad region, and our on the ground information is located to the area right in the mine study area, relatively close to the deposit.
And you're how does this relate then to the reclamation effort in the future, as far as recreating some of these soil types that are out there? Will there be, I know this is somewhat looking into the future, but in your work, has there been any contact with the mine people in talking about reclamation work as far as reconstructing the soils?
Yeah, so really what this is talking about is just, it's just baseline, what's there now, and what, just sort of the physical component of it. So the general characteristics of the soil and the kind of the volume thickness of it. So, yeah, there might be more detailed study needed to do with reclamation. This isn't part of the reclamation plan.
Yeah, when we were out there in late August, there was some reclamation work at the individual drill sites, and unfortunately we didn't get to go over and check those out, but I'd like to see those at some point and see what kind of vegetation is being used and that sort of thing. But there is a very strong effort on your part to reclaim some of those areas.
What they do at the individual sites right now is they actually cut the tender vegetation and the topsoil into pieces and put them aside. And then when they put all the original soil material back into any holes that they dig, and they put that stuff back on top.
Okay, so there isn't any actual replanting as such.
No.
It's a replacement.
Yeah.
Okay. The studies that were cited, the one by Clark and Ping in the Chesapeake Island area, and the one by Hinton in the Non-Dalton area. There's also a study by Kelly that post-dates the 2008 end of the baseline studies. But that particular study by Kelly, they looked at soils across the deposit or across the prospect area. And that needs to be looked at, I would think. There's also some...
Sorry, excuse me, which agency was that?
That's USGS,
Okay.
Karen Kelly and Bob Eppinger and some of those people. And they actually did sample soils. There's also some work that was done back in the 80s in the Caps coalfield area west of Tyonek, and that may be a good reference for you. I mean, there's some good geochemical data for soils from that area that might help. There's also a characterization of the soils from that area too. So that might...
Yeah, that's definitely, thanks.
Yeah.
We'll
Okay. I can give you those references. Yeah.
Thanks, Larry. Tom, do you have all our panelists don't have to have questions on each one because of different expertise, but we'll work our way through this.
I think at this point I'll reserve. I have been thinking mostly about the acid mine drainage, geochemical characterization issues, and there are some questions that relate somewhat to mineralogy and geology, but I think I'll wait until tomorrow when the consultant that has done that work should be present at that time.
Thanks. Steve?
Yeah, just a brief comment. I don't recall seeing much about the character of the soil in terms of its effect on seismic shaking. The idea here is that if you have very thick, soft soil, soft sediment, that they can enhance the shaking. It's kind of like shaking a bowl of Jell-O. Here, it seems like most of the soils are relatively stiffer and thinner, and so I don't see any direct impact on the seismic shaking. Any comments or thoughts?
Yeah, I think, well, we've got a seismicity session this afternoon, so I think I'll leave it to our seismicity expert.
Thanks. Chris?
Okay, I'll just make some comments. The parts of this EBD that I looked at had to do with surficial geology, geomorphology, hazards, things like that. And so as we heard this morning, the surficial geology was mapped at a scale of 1 to 50,000. Map was published by the Alaska Division of Geological and Geophysical Surveys, not the USGS. That was up on one of the slides. And that work was done by Tom Hamilton, who is a emeritus scientist with USGS, now a consultant, retired from the survey. And the report itself goes into some detail on the nature of the unconsolidated quaternary age deposits that cover the mine area. As we also heard, area was extensively glaciated multiple times, and the write-up in this geologic report about the superficial geology has a very distinctive glacial geologic slant to it. So if you read that, you'll get that impression right away. There was some mention made about pattern ground, frost action, but I think the general idea is that there is really no active permafrost in the area. I think that came through. Most of the features that were described are relic features, that they were active previously during a colder period of climate during the last ice age. The mapping itself is pretty much state-of-the-art. There's really not much to fault in terms of the scale, the kinds of features identified, the characterization of the different types of deposits. So it's very relevant to trying to assess engineering concerns that would deal with superficial deposits. So I think from that standpoint, that particular piece of work is without fault. I can't really comment too much further. The map itself was made, as I said, by Tom Hamilton and then reviewed by two other well-known quaternary geologists in Alaska, Dick Rieger and Rod Kumbelek, who both work for the state. And so they also put their stamp of approval on it, as I do. The other section of the report that I'll just make a few comments on has to do with the superficial geology of the transportation corridor, which I think is shown in yellow and orange over there. Now, in contrast, the amount of detail supplied for that area was pretty limited, probably by design. I'm assuming you're going to do more with that as appropriate. But there was basically 2 sentences in the report that described the superficial geology of that big area, which in my view isn't quite adequate, given what was done for the mine site itself, which was very detailed. So you guys probably already know that, right? So,
I mean, I guess, yeah, I mean, there's different information needs for the different areas, but yeah, there's definitely a lot of detail in one and very little in the other.
Right.
We acknowledge that.
Yeah. Yeah, more maps and diagrams and a map, maybe not as detailed as Hamilton's map, would be useful. As far as the physiography chapter 28, we heard some more about that. I just have some minor points that I'll share with you guys a little later because it's not really that significant. But a lot of the details about relief, sizes of streams, flood frequency, and some of the hazards I think ought to be in there. parts of the road system encounter some fairly steep terrain, and there really wasn't much discussion of slope stability issues, landslides, snow avalanches, things like that, which are likely to happen. What else here? And I mean, the rationale, I kind of get, as a standalone document, the chapter itself didn't make a lot of sense, but in the context of the whole report, I see what you're after. I just want to give a sort of sense of the geomorphology, the lay of the land in a snapshot. But as a standalone chapter, it sort of hangs out there. Like I say, I have some detailed minor comments that I'll pass along on that. So that's all for me for now.
Thanks, Chris. Do the panelists have any more questions? Okay, Jeremy.
Yeah, I'd like to just reiterate that concern about the lack of detail in the transportation corridor, specifically on slope stability, because a long section of that corridor runs right along the north shore of Lake Giliamna, right below some pretty steep-looking cliffs. And I think even in one of the photographs you showed of a road there looked to be some pretty good landslides coming off the side of the hill above that. And that transportation corridor, it's not discussed really in the EBD as to what that corridor is to be used for, but presumably, and you can see that in the 43-101 report, that corridor is anticipated to be used for piping concentrates to port, and suggestions of possibly other pipelines returning back up to the mine. So that corridor, the landslide risk along that route is quite severe if you have pipelines along there. If you're just driving trucks up and down it, then the risk is 1 in a million that you get hit by the landslide. But if you have a permanent set of pipelines there, it's going to get taken out by a landslide. So presumably there needs to be some evaluation of the frequency of landslides, what might trigger them, seismic triggering, or is it annual, freeze-thaw effects. Do you want to comment a little bit on that?
Yeah, I think the main issue on the transportation corridor study area is that it was quite a broadly defined corridor, and there wasn't a specific alignment for various linear features identified yet. So some of the things you're describing would definitely need to be done, but they're quite site-specific. You wouldn't necessarily look at the landslide hazard through that huge, wide corridor that we had. You'd wait until you'd decided on alignment and look at those specific hazards. Mm-hmm. So I showed a photo of the existing road going up over the pass from Bristol Bay into Cook Inlet. There is an existing road there, but that may or may not be part of the transportation corridor. It's just it's kind of the easiest way to fly through in a helicopter, and it's got an obvious focal point because there's an existing road, but it's not necessarily where anything would go. So I think it's recognized that those would be kind of part of a detailed study for a final corridor.
Anything else from the panel?
Yeah, I have one question, and that has to do with the possible integration of your work, the soils overview, with the soils that were collected by the folks that were sampling vegetation, as well as some of this. There were, as I understand it, in the trace element work, there were some soils also collected. Was there any integration between those three studies that, as far as characterization and that sort of thing? Yeah,
really, this soil study is just about the. It's pretty high level, and it's just more kind of volumetric thickness and general characterization. Then each of those, sort of the chemical or biological studies, I mean, they have access to this information. It's kind of a one-way street, I guess. They have access to this information, but we're not trying to present those things here.
Okay.
You know what I mean? So yeah, there's some integration.
Thanks. Any other comments or questions from our panel? Jeremy?
One last observation, I guess. One of the defenses or weapons against acid mine drainage is carbonate rocks that you can use to neutralize those acids. from reading the report, I didn't see that there was much carbonate rock in the regional geology. I think there was one mention of a carbonate unit within the sequence, but nothing of any substance. Are you aware of any other carbonate resources, limestones or something, that would be available to the mine in this region that could be used for treating acid drainage?
There is actually quite a bit of calcite infill in a lot of the bedrock, but I don't think anybody's looked at the amount of calcite that's available yet.
Mm-hmm. Okay, thanks.